As a final example, we're just going to work with one curve and calculate all the quantities we've been studying on that one curve. The curve is a helix of radius 3 that's opening up at 4. For every 1 unit increase in t, you go up to 4 units in height z. So what we're going to do is just start by finding the derivative of r with respect to t, which is negative 3 sine t, 3 cosine t, 4. After I've done that, let's find the speed. The speed is the square root of, here I've got a 9 sine squared, plus a 9 cosine squared, plus 16. These add together to give me a 9 plus 16, which is the square root of 25, or just simply 5. The next thing we're going to calculate is t, which is r prime over the magnitude of r prime. So that's essentially minus 3/5, minus 3/5 sine t, 3/5 cosine t, and then 4/5. That over that. T prime is, take the derivative, so negative 3/5 cosine t, negative 3/5 sine t, 0. If I want to get the curvature vector, that's t prime over speed. This is our speed. So the speed is 5, so take this vector and divide it by 5, which really means I just need a 25 in the bottom. So I have a negative 3/25 cosine t, negative 3/25 sine t, 0. If I want the curvature is the magnitude of the curvature. And, well, this is just a circle. I could pull the minus 3/25 out, or 3/25 out, and then I'd be left with the circle. So really, this is just the radius of that circle, or 3/25. The radius of curvature is then the reciprocal of that, 25/3. The next thing we're going to get is to get n. To get n, I can take the curvature vector and divide by the curvature. So all I really need to do is take the 3/25 out of this vector here, so divide everything by 3/25, giving me a minus cosine t minus sine t, 0. As a check, the length of n should be 1, and it is, because that's just a circle of radius 1. To get b, I take t cross n. So we'll come and grab t, which is a negative 3/5 sine t, a 3/5 cosine t, and 0. N is negative cosine t, negative sine t. Oh, t has a, sorry, that's a 4/5 there. And that has a 0 there, and then I need an ij. Okay. So we take 0 minus, so that's positive 4/5 sine t, and then that times that is 0 minus that times that makes a positive 4/5, but it needs to be negative, so negative 4/5 cosine t, and then I need positive 3/5 sine squared plus 3/5 cosine squared is equals the square root of, I need to take that's 16/25 sine squared. Oh, what am I doing? So I made mistakes as well. I just need to simplify this. This is a 3/5 sine squared cosine squared. So that really is 4/5 sine t, negative 4/5 cosine t, and then 3/5. That's my b. So if I want to get torsion, I need to find the derivative of b with respect to s, which means find the derivative of b with respect to t, and then divide it by speed. So I need the derivative of this with respect to t, giving me negative 4/5 cosine t, negative, oh, that's positive 4/5 cosine t, positive 4/5 sine t, 0. And then I need to divide it by speed, and the speed is 5. This vector points, how does it compare to n? Notice that it's got a cosine and a sine and a 0, but it's the opposite direction. This is essentially a 4/25 cosine t, sine t, 0. The length of dBds is this 4/25 times the length of that vector, but the length of this vector is 1. So it's 4/25. Because the torsion vector, or because this derivative of b with respect to s is opposite in, torsion is positive 4/25. The only thing left is we now need to get a sub t. To get a sub t, I can just take a and dot it with t, but have I found a? A is the second derivative, so let's just go and quickly find it. The second derivative would be negative 3 cosine t, negative 3 sine t, 0. So if I take that and dot it with t, then the dot product of these two things is a minus 9/5 or a positive 9/5 cosine squared t, and then a positive 9/5 sine squared t, and then 0. And I'm doing this all wrong because that should be 0, and I botched it. I'll have to do that again another time.